All right, let's learn about real zeros of polynomials. And to do that, let's learn about the factor theorem. Okay, what does it say? It says that I've got some polynomial p in terms of x, and let's say that some number a makes that polynomial equal to 0. If that's true, then x minus a is a factor of that polynomial. Conversely, if I know that x minus a is a factor, then that means that p of a has to equal 0. In other words, a is a 0, a root, a solution of the polynomial p of x. All right, so let's say we're given that -3 and 5 are zeros of this polynomial. Let's determine all the other real zeros and write p of x in terms of a product of linear and or irreducible quadratic factors. Okay, so what that means is if I do synthetic division with -3 on my polynomial, I should get a remainder of 0. And if you don't know what I'm doing with synthetic division, go back to my YouTube channel and look at the synthetic division screencast I made. It's not very long. Okay, bring down the 1. 1 times -3 is -3. Add the -2, that's -5. Times -3 is +15. Add the -11, that's 4. Times -3 is -12. Add the -8, that's -20, times -3 is +60, and yes, we do get a remainder of 0. Okay, now I'm going to work off of this new quotient, and I'm going to put in the other number I'm given to be a 0. Bring down the 1. 1 times 5 is 5, plus -5 is 0, times 5 is 0, plus 4 is 4, times 5 is 20, and a remainder is 0. Okay, now this quotient right here is degree 3 because we started with a 4th degree, and this is degree 2. And once I get down to 2nd degree, I can solve it either using factoring or the quadratic formula, whatever. So what do we have here? We have that p of x is equal to x minus this 0, that's going to be x plus 3, times x minus this 0, so that's x minus 5, times x squared plus 4. That's x squared plus 0x plus 4. Now, can I factor that? I actually can't, because if I did x squared plus 4 equals 0, I would get x squared equals -4, and there are no real solutions to that. So we're supposed to write it in terms of all other real zeros. And that's it. Another helpful theorem is the rational zero theorem, and this says if I've got a polynomial, just a standard polynomial, and it has to have integer coefficients, folks. If it doesn't have integer coefficients, then this won't work. But if it does, then every rational zero of p of x has the form of all the factors of the constant term, that's the last term, divided by all the factors of the lead coefficient. Okay? Now I'm going to do an example so this will be clearer. Okay, so let's use the rational zero theorem to list the possible, notice that this is not the actual, these are all the possible rational zeros of this polynomial. Okay, so all the factors of the constant term a sub 0 are plus or minus 1, 3, 7, and 21. Those are all the factors of -21. All the factors of the lead coefficient are 1, 2, and 4. So all possible rational zeros are going to be all of these numbers divided by all of these numbers. So you ready? Here we go. It's going to be plus or minus 1 over 1, plus or minus 3 over 1, plus or minus 7 over 1, plus or minus 21 over 1. Plus or minus 1 over 2, plus or minus 3 over 2, plus or minus 7 over 2, plus or minus 21 over 2, plus or minus 1 over 4, plus or minus 3 over 4, plus or minus 7 over 4, and finally plus or minus 21 over 4. Are all of these numbers actual zeros? No, of course not. Later on we're going to see that we're only going to get a maximum of 6. But if there are rational zeros They have to come out of this list. That's what this theorem is good for. Okay, so let's take it one step further. In this example, we're going to determine the possible rational zeros for the polynomial p of x equals x to the fourth minus x cubed minus 5x squared minus x minus 6. So all possibles are the factors of the last term, the constant, divided by the factors of the lead coefficient, which in this case is 1. So that means it's just going to be plus or minus 1, 2, 3, and 6. Okay, so we have 8 numbers to try. Use our list to find the actual rational zeros. Okay, so let's try 1. So I've got 1x to the fourth minus 1x cubed minus 5x squared minus 1x minus 6. Bring down the 1. 1 times 1 is 1. Add to 1 is 0. 0 times 1 is 0. Add to negative 5 is negative 5. Times 1 is negative 5. Add to negative 1, I get negative 6. Times 1 is negative 6. And my remainder is not 0. Therefore, 1 is not a rational zero. Now, I went ahead and worked it out, and in the interest of time, I happen to know that negative 2 does work. Okay? So I'm going to put out my coefficients here. Bring down the 1. 1 times negative 2 is negative 2. Plus negative 1 is negative 3. Times negative 2 is positive 6. Minus 5 is 1. Times negative 2 is negative 2. Plus negative 1 is negative 3. Positive 6. Yay! So we know negative 2 works. We're going to save that. Okay, now let's try another number, and I happen to know that 3 works. So I'm going to bring down the 1. And 3, 0. 0 times 3 is 0. 1. 3 times 1 is 3. Plus negative 3 is 0. Okay, so at this point, we are at a quadratic. This is x squared plus 0x plus 1 equals 0. So all of our, and if I go ahead and solve that, if I go x squared plus 1 equals 0, x squared equals negative 1, no real solution, so I just don't worry about that. So all possible rational zeros are negative 2 and 3. That's it.